Hi, students. This is Coach Brian. I want to talk to you about area of circles. We're going to find area of a circle. So, question just to kind of tickle your brain. So, how do we use a square unit to measure something like a circle, which is round? Because you wouldn't seemingly have an exact measurement. So, it's really about square equivalency. Now, there's other examples of like an equivalent unit of measure that's not literal. So let's think about the term horsepower. The term horsepower is used to measure the rate at which work is done. When originally used to measure the steam engine's output, it was compared to the work of a draft horse. So when they talked about the horsepower of a steam engine, they were talking about a mechanical engine, not that the engine was horses working. So in the old days, it was pretty basic, but now we have complex formulas to derive horsepower, and we use those to measure the output of the engines in a car. So there's not literally horses underneath the hood of your car, kids. Just in case you want to look under the hood of a car, there will not find actual ponies eating hay. So, but it's like the way we use a square unit to measure the area of something that doesn't have corners. So, to further this example, we're going to compare by making bean pie. All right, so we have a circle on the left and a square on the right that has that same size circle inside of the square. Now we fill the circle area with beans. There's our beans inside of our circle. And we're going to measure the diameter of the circle. It can be compared to the side measurement of a big square. So the side of the big square and the diameter of the circle are the exact same. Okay? So the circle's radius can be compared to the smaller square that comprises the big square. So there we have a small square with a side measurement that's equivalent to the radius now of the circle. Okay, so we're going to take the radius of the circle and we're going to square it. So I'm going to take that side that's equal to the radius and square it. Now, so if the radius is equal to, so let's call it 3, then each side of this square is 3. The radius is 3. The side measurement of the small square is 3. So to find the area of the small square, the area of a square is s squared. Just so we would say that the area of the small square is made up of obviously square units. That small square has an area of 9 square units. So let's move the beans that fill the circle, the beans on the left, fill the circle, and see how many of these 9 square units we can take up in the big box. Okay? So there you go. The beans from the circle filled up a little bit more than 3 small squares. A little more than 3. Where have we seen that before? A number that's a little bit more than 3. Think about a number that's a little bit more than 3. Oh yeah, it's pi. So let's recap. Now we're writing in our notes. Next to let's recap, write the circle area is A equals to pi times r squared. So number 1, get the radius. Write that down next to number 1. Get the radius. So in this case, the radius was 3. R equals 3. Number 2, we're going to square it. Write down square it for number 2. That means to multiply by itself. Multiply by itself. That means r squared is equal, in this case, to 3 times 3. We're still talking about the bean pie square above us. Now the third step, 1, 2, 3, Now we're going to multiply times pi. Multiply times pi. So, first check mark, pi r squared equals 3 times 3 times pi. Second square. Second check mark, pi is approximately 3.14. For those of you curious why we use the squiggly approximate, because technically, if you try to substitute a number for pi, it's never going to be exact, so we use the approximate sign. Third check mark, pi r squared, therefore, is 3 times, and we're going to use 3.14. It's approximately 3.3 times 3.14. So last check mark, if we multiply 3 times 3, we get 9. If we multiply 9 times 3.14, we get 28.26 square units. 28.26 square units, and that's a little bit more than 3/4 of that big square, which would be 9 by 9, or I'm sorry, 6 by 6, or 36. Okay, so describe the steps. We found the area of the circle by 1, getting radius. We have to have the radius. Number 2, squaring the radius, r times r, or r squared. And 3, multiply by pi. Step 3, multiply by so step 1, get your radius. Step 2, square your radius. Step 3, multiply times pi. 3 simple steps to find the area of a circle. Going to our example page. All right, so in this example, we'll look at number 1. Example number 1, the formula again is area equals pi r squared. The radius is 2 centimeters. So we're going to plug in our formula, area equals pi, and we'll substitute the radius squared, 2 times 2. So the area would then be pi times 4, and pi times 4, if we substitute 3.14, is 12.56. 12.56. All right, I'm going to slow it down a little bit. We're on example number 2. See if you're getting the hang of this. For example number 2, we have a diameter of 2 centimeters. What's wrong with this? What's our first thing we need? That's right, we need radius, not the diameter. So the radius is half of the diameter. So instead of 2, we're going to use 1. Next step, pi times 1 squared, or 1 times 1, which means we're basically going to multiply 3.14 times 1. So what do you think the area of the circle with a radius of 1 will be? Yay, that's right. It's 3.14 square centimeters. All right, example number 3. Same formula, area equals pi r squared. We have a diameter of 12 centimeters. Can't use that, right? So what are we going to use? We will use a radius of 6 centimeters. Now we're going to plug 6 centimeters in for our radius. So area is equal to pi times 6 times 6. So area equals equal to pi times 36. Now I'm going to give you a moment. We might need to pause the video and let you multiply 36 times 3.14. You can pause the video now if you need to. I'm going to keep going in 5, 4, 3, 2, 1. Here we go. The area of a circle with a radius of 6 centimeters would be 113.1 square centimeters. All right, example number 4. That's not really a circle, is it? Like a piece of pizza. Well, we're still going to use this formula But this looks like a quarter of a circle. So let's proceed because we will be given a radius of 6. So we just did, this is similar to the last problem, so pi times 36. Pi times 36, as you know, is 113.1. But now what? Because we don't want the whole circle, we only want 1/4 of the circle. So if we want 1/4, we can multiply times 1/4, or we can divide by 4. It's the same thing. So if we multiply 36 times 1/4, and I'll give you some time to multiply 113.1, pi times 36, that is, times 1/4, or divide it by 4. I'll give you a few seconds to do that. Maybe we can pause. Let's pause it, or not. I'm going to start again and give you the answer in like 5, 4, 3, 2, 1. There you go. So the area of a quarter of that circle is 28.27. And I hope you can make the connection there between the example number 3, the full circle at 113.1, and a quarter of that, which is 28.27. And that's basically finding the area of circles. I hope you kind of understand that these square units are equivalent. It's an equivalency. It's not a literal type of thing. Good luck on the practice and your homework tonight on this. Thank you for watching.